Am I recording? Okay, here we go. Let's look. So yesterday, arctan inverse tan of x, then find the limit as x approaches the square root of 3 of all that stuff. What's it asking me to do? Find the derivative. Anytime we see that limit, it's asking me to take the derivative. So if y is inverse tan, then dy dx is going to be 1 over 1 plus x squared. And what's the x value we want to put in there? Square root of 3. So 1 over 1 plus the square root of 3 squared will give me 1 over 1 plus 3, or 1/4 B. Okay, that's where we should land. How'd you do? Hey, y'all got the wrap up right yesterday. That made me feel good. Yeah, I put that in my thing. I checked the wrap up and they all got it right. Woohoo! It's all good. All right.
Yeah, exactly. I'm gonna get it right.
Okay, I love this one too. We are powerful because we can do calculus. Okay, just saying. When you go off, like we're just gonna take the whole city block with us. All right, calculus is the most powerful weapon of thought yet devised by the wit of man. All right, so today we're going to talk about using varied procedures for calculating derivatives. How do we know when to do what thing? All right, bless you. Because when we get to the AP exam, they're just all lumped in there together. There's not a section that says, hey, you're going to use the chain rule on these. Right? They're just all together. Sorry about that. And then how to take higher order derivatives. All right. So here are, quick review. Here are the things we've learned so far. The main operating procedures: product rule, quotient rule, chain rule. And then I would add to that just your basic, I like to call it basic, general power rule. All right. And so that would be if I have y equals x to the n, then dy dx is n times x to the n minus 1. So just our basic power rule. Okay. So those are the main things we've learned. Right. And then we learned all the special rules for trigs, for trig functions, for ln's, for inverse trig functions, for e's, for logarithmics of any base, and exponentials of any base. Okay. So what I want us to do is, the first part of the lesson is just kind of looking at some and figuring out which rule applies here, all right, or which combination of rules we need to use, okay? Because if I don't recognize what to do, I don't know when to do it, all right? I can't possibly get it right. So let's take a look at this first set of 4. One of these does not belong. Let's see if we can figure out which one that would be. All right, and there's a lot going on in these. Bless you. All right. What do you think? Any thoughts?
Right.
Bottom right. This one? Okay. Why do you say that one?
It doesn't have anything with the E in it.
All right. Doesn't have anything with an E in it. Okay. Any other thoughts? I guess. All right. So this is the only chain rule. Okay. Is that what you were going to say, Jacob? Okay. All right. What type of procedure will we need to use on this first one to find its derivative? Product rule, yeah. What about the one underneath it? Product rule. That one we said was chain rule. What about that last one on the bottom left? Right. Product rule. Okay. And that's probably what they had in mind, is that we would choose that one on the top right because it's the only one that requires the chain rule. But I like how Neve thought about that in terms of it's the only one without some form of E in it or the LN. Okay. But yeah. All right. So just looking at what's required to do the derivative, all right, the derivative procedure. All right, so here's what I want you to do. Flip over to the next page. Okay. So what we want to do is we want to match the procedure. So we're going to have lots of lines here needed to compute each derivative. Would I need just the basic rules? Would I need, let's just start with what's the primary thing we'd need to do, okay? Would we do a product rule? Would we do a quotient rule? Would we need a chain rule? All right. And some of them might need more than one thing. So, all right, take a second, see what you think. Or you can just write out next to them. It doesn't matter. If you don't want to draw the lines can get confusing. All right, so just recognizing our procedures that we might want to use to do. Bless you. What are your birthday plans?
I don't really know.
Okay. All right. Does your mom do anything like for breakfast on your birthday? No?
It's usually be cooking, but I don't know.
Y'all. My iPad's not turned off. Was it a Wi-Fi glitch again? This happened yesterday during my lesson. It stopped mirroring. Okay. My brother always does for his kids donuts. So he goes and gets donuts and has donuts when they get up. I never really do anything for breakfast for birthdays. Like in the morning time, we just always celebrate like when we're all together in the evening. Except this year I had Becca's present out on the table and she insisted that she open it because she saw it. And she turned 23. Okay, so just saying. I was like, you're not gonna have anything to open at dinner. I don't care. Okay.
Do you know how long she wants to live?
I think until she has the money to possibly put a down payment on a place instead of having to, or she gets married, one of the two. So, if you know any handsome 20-something-year-old young men, you know, that have a good job or stable, good to their mamas.
Never heard of that.
Yeah. You know, that's what she's looking for. I don't know. She has a journal. She's been writing to her future husband since she was 15, I think. Yeah. She's been writing to her future husband since she was 15.
Aw.
So she has a journal. I don't know. That's just what she said she was doing. And I was like, okay.
Someone did that for me.
I'm gonna have to go home and watch the Notebook.
Watch the what?
The Notebook. Watch The Notebook.
Oh, such a good one.
That's the only movie that makes me cry every time I watch it.
Well, they've made a musical out of it, but I've not seen it. When I read the book first and sobbed like a crazy person, and then you watch the movie and you're like, I'm still crying, even though I know what's going to happen.
Wait, did we watch it together?
Maybe? I feel like we did.
Did we start Titanic?
Yeah.
Why didn't we watch The Notebook?
Most Forrest Gump.
Oh, I love Forrest Gump. If it's on, I'll watch it.
Those three movies are all the same.
It is sad, but I love it so much.
Shrimp hat.
Oh, I miss shrimp. I love shrimp, but now I'm allergic, so it's so frustrating. Like, cause when you go to the beach, right, and they go to eat seafood, I just roll my eyes because I'm like, can we go eat Mexican at the beach? Because they're all getting shrimp this and shrimp that and shrimp, and I'm like, I'll take the grilled fish. So I won't even try like anything shellfish related anymore.
Eat
Just
salmon?
yes, I mean I like salmon. I like salmon. Do I say it different? What did you say?
Salmon's good.
Yes, I'll say it as salmon.
My girl has salmon.
Yep. I don't like salmon patties though. Like,
Oh my gosh, those are freaking disgusting.
and they smell so bad. My mom and dad will cook them. Like she warns me. She's like, "Don't come over today and make salmon patties." I'm like, "Okay." Because when I walk in, I go, "Ugh," like every time.
Okay, guys, did it smell horrible outside today?
Yeah.
Like when you were driving to school this morning?
No.
Just here close to school, because
Yeah,
that
by the fairground.
oh, because that food that meat factory.
Oh, that's what it was?
Yeah, they make barbecue and
I
stuff
thought
over
somebody
there.
was like hiding in my car and ripped one. I was
No, it smells like sewer. It's bad.
Yeah.
Yeah, but it's from that barbecue plant or that meat processing plant. It used to be called Byron's Barbecue. Some of the best barbecue you could buy, like in the store. Ooh, it was so good. Anyway, okay. What about this first one? What are we going to need to do to make that one happen? Product rule. Okay, so this is going to be product rule. All right, what about the next one? Anything fancy to do e to the x plus 3 sine of x? Yeah, it's just basic. Okay. What about e to the x tan x? Ooh, that's a chain rule. In that chain rule, what are you going to have to do for that exponent? That's a product rule. Yeah. Inside of that, it's going to be a product rule. What about that 5x ln of x? Product rule. Cube root of 4 minus x squared. Chain rule. Okay, remember this is 4 minus x squared to the 1/3. All right, so that's going to require the chain. Chain. What about the next one? Chain rule again. ln of 5x squared plus 1. Chain rule again. Lots of chains there. 3 over x to the 4th. You can do this with basic rules. You could do quotient or basic. I personally would do this so that I could do a basic rule instead of a quotient. Okay, I'd rewrite it as 3x to the negative 4. Okay, if I don't have to do a quotient rule, I don't. Right? What about the next one? E to the x over sine x. That's definitely a quotient. And sine x over e to the 2x plus 3. It's a quotient, but when I'm messing with that denominator, I'm going to need a chain as well. Okay, so that would use 2 different things. Okay, so we understand kind of just learning to look at what we need. One of the things I noticed on your implicit differentiation quiz when I graded it yesterday is not recognizing when you have to do a product within that implicit. Okay, so just be careful with that. If you have 5x or 5x squared times y, that is a product derivative, even though it's implicit. Okay, so that was just one of the common mistakes that I saw in that as I graded it. I'm going to pass those back here in just a second. All right, they're already in the grade book. You can look on Skyward. Okay. All right, so let's take a look at this one. So it says if f of x is equal to x squared plus 2x, then the derivative with respect to x of f of the ln of x. Play with that a minute. How do we do that? Okay, this is pulled from an AP website. Bless you.
I'm gonna think. I'm gonna think this way.
Oh, somebody punched a hole in the sky.
Makes Kanye still breathing.
Maybe Santa will bring me some more for Christmas.
No. But it's okay. His Kanye, he's very resilient. Does anyone have stitches? Are these stitches from Kanye? No, oh, definitely. Kanye is immortal.
Is this when you use the all-up thing?
Very,
You don't have to,
very
because it's LN.
maybe it will bend up a little. Wait, what's the fuss about? Kanye.
Somebody.
Yeah, somebody.
All right, let's look.
Sprite, someone will take it.
Let me do it by.
Actually, I don't know.
Okay. So we want to take the derivative of f of the ln of x, okay? So what I'm going to do is actually complete that composition, all right? Which says everywhere that I have an x in f, what am I going to put in? ln. So my actual function is, all right, I'm just going to rewrite it as y, ln of x, quantity squared, plus 2 ln of x, okay? And now we want to take a derivative, okay? So y prime or dy dx, chain rule, 2 ln of x times the derivative of the inside stuff. What's the derivative of ln of x? 1 over x plus 2 ln of x. I'll keep the 2, and what's the derivative of ln of x? 1 over x. Remember, if it's just a coefficient, you don't need a product rule. You just keep it, okay? And so then if we simplify, that gives me 2 ln of x over x plus 2 over x. Or if I put it all together, since they have a common denominator, 2 ln of x plus 2 all over x, which should be a. Okay? So you probably made it harder than it needed to be. Story of my life. Okay. All right, try the next one. Parker, I wrote you a note back on your quiz. It always makes me giggle when people write me notes. So roll back.
My note didn't make me giggle.
Neither did your grade. Sorry, that was a little low. That was a little cold-blooded. I apologize.
That was cold.
Yeah, I was. I'm sorry.
That was great. That was great.
I did. I'm sorry. That's why y'all hide my animals. It's okay. Sometimes the rage just comes out. Trying to do better.
Okay, so in some aspects, but a whole lot more than that. A whole lot more.
Phone is being held.
These are called decimal.
Yeah.
All right, so did you get this to start? Okay, so derivative of ln's 1 over 2x plus y, the chain derivative of 2x plus y would be 2 plus dy dx. It's important that we put parentheses there, okay? One of the things on your quiz, again, is just the lack of getting the parentheses in the right spot, which changes your final solution, okay? So you have to be careful there. We want to solve for dy dx, which means I need to move this 1 over 2x plus y, okay? So to do that, I'm just going to multiply by 2x plus y. So I have 2 plus dy dx equals 1 times 2x plus y, okay? Well, now I don't really need those parentheses anymore, okay? So I can take that 2 over to the other side. That leaves me with dy dx equals 2x plus y minus 2, which is b. Okay, so a little implicit there with the chain rule and all the good things. Okay, so none of that's going away. Okay? All right. So let's jump into higher order derivatives. That's the last kind of new thing. The first part of this was just kind of review, being sure we can pick out which procedure we need to use. The great news is that higher order derivatives just mean that we continue taking the derivative of the previous answer. Okay, so we just continue taking a derivative. If we want a second derivative, we take the derivative of the first derivative. If we want a third derivative, we take the derivative of the second derivative. Like, you just continue to take a derivative, okay? Let me show you the notation, okay? So our first derivative would be y prime. Our second, y double prime. Our third, y triple prime. Okay, now if I wanted the 50th derivative, are we going to put 50 little marks out next to it? That would be awesome, but no, we're not, okay? So once we do anything plus, okay, so 4 or greater, that's not how that is written, hold on. okay? So 4 or more derivatives, we'd use a parenthesis and what looks like an exponent. The parenthesis is the notation that it's not an exponent, okay, that it's a derivative, right? Likewise, if we use the other notation, okay, yeah.
Is there anywhere we actually have to deal with the 50th derivative?
Yes, because you can in trig functions. Why do you think you can in trig functions?
Oh, because they repeat.
They repeat. Yeah, trig functions, I think you actually have a problem that asks you to do something like the 24th derivative of something. You look at a pattern. You don't have to do 23 derivatives. You look for a pattern and it's easier. All right, but let's talk about the other notation. So the first derivative, we already know dy dx. Okay, now the second derivative, and this looks a little bit weird, okay? We're taking the second derivative of y with respect to x the second time. Yeah. Okay? So d2y dx squared. It's kind of a weird, but it's the second derivative of y with respect to x for the second time. Nobody's going to say all those words, but that's what it is, okay? And the nice thing about this is that we continue it regardless of how many derivatives we're going to take. d3y dx3. If it's the 50th, d50y over dx to the 50th. Okay, so we don't have to swap notations because we're not using little symbols. We're actually using this formal notation. Okay. So let's start simple, and then we'll work our way up to the more complicated things where we have implicit and chain rule and products and quotients and all the things. All right, but let's start simple. We're just going to take multiple derivatives, which is kind of nice. Okay, so let's find the first 4 derivatives of y equals x cubed minus 5x squared plus 2. Okay, so first derivative y prime. Do I need anything special to do these derivatives? No, they're all power rule. So 3x squared minus 10x is my first derivative. My second derivative, 6x minus 10. So bless you. We're just taking the subsequent derivative. Bless you. All right, the third derivative of 6x would just be 6. And then what would my fourth derivative be? 0. Okay, so those are the first 4 derivatives of that function. Okay. All right, you try that one underneath it. Find the third derivative. All right, so f prime would give me 8x cubed minus 5 plus cosine. F double prime, 24x squared minus sine. And then f triple prime, 48x minus cosine. How'd you do? Did it. Yeah. So there's a little Dora for you. Dora, the Explorer. Swipe or no swipe.
Okay, Josh?
All right, try the next one. Number 9. Then we're going to get to the good stuff.
You know, Instagram wants to put 20 pictures in one post now. That is too much. Nobody's fun to do 20 things. Well, I do all.
I do, always.
I always do, but, I mean, 20 pictures, I don't even have 20 pictures in my phone.
Oh, I won't tell you how many pictures I have on my phone. But I do transfer them to Google to Google Photos every so often. Like I put so many, like when I cleaned out my closet initially, I had so many pictures I had to end up doing it in 2 posts of things that I was selling. I was a little bit embarrassed. Apparently 100 pictures is the most you can have. I made strawberry limeade this morning. It was good.
The derivative of secant is secant tangent.
That is correct.
Wait, the derivative of secant, that's what they're getting.
Yes.
Okay. Wait, you just asked that?
Yeah,
Oh,
the derivative
okay.
of tangent is,
A tangent, that's just secant squared.
okay.
Or am I just bugging?
Nope, you're correct. No bugging.
Actually, I do it. Sorry, it's just, I had
I love your screensaver, by the way. You're on
It's
screen.
an original piece. This was either sophomore or junior year.
Okay.
I won't try to delete it, but I sent it to my personal email.
What are you doing, Oakley? Looked like you were trying to shoot Parker a bird in that picture. Doesn't it? Arc, arc. All right, so let's do this first derivative. Derivative of secant is secant tan. Derivative of e to the x is e to the x, thank goodness. Okay. Now, when I get ready to take this second derivative, the first thing we have to notice is that this is a product rule. Okay. This is a product rule. So here we go. First, times derivative of the second plus second times derivative of the first, which would be 2 secant tan. Okay. Then derivative of e to the x tacked on at the end. Okay. Let's simplify. Nothing really crazy is going to happen here, except how many secants do I have multiplied together right here? 3 of them. So 2 secant cubed of x plus, here I have a secant and how many tangents? 2. So I have 2 secant x tangent squared plus e to the x. And that is my second derivative. Okay, so we just put all of our secants and tans together, but the trick here people miss the most is that that is a product rule, all right, in that second derivative. Okay. All right, so let's walk through number 10. We're going to kind of walk through this one together. The rest of these get a little more complicated, okay, just because, well, we got to, all right. So You'll notice I left you a lot of space. Okay, because I'm going to start with a quotient. More than likely, it's going to stay a quotient unless I recognize something along the way. Okay, do you notice anything about this y rational function that we could work on before we started taking a derivative? Yeah, it's a difference of squares up there at the top. Okay, so could we rewrite y as x plus 2, x minus 2 over x plus 2? Yep, we sure could. And so then what's going to happen? Yep. And I end up with y is the same thing as x minus 2. Okay? That's a lot easier to take a derivative of. Would you agree? All right, here we go. So dy dx is going to equal what? 1. What's d squared y over dx squared going to be? 0. Okay? So watch those kinds of things. Okay? Look for them. If I can avoid doing all this crazy quotient rule, then I want to do so. Okay? So always check, can I simplify? Sometimes you won't be able to. All right? And that's okay. It is life. Okay? Flip it over. The next one, in my personal opinion, is the hardest one we do. Okay? So, just so you know. Now, the reason it becomes so difficult is because we're talking about an implicit relationship. Okay? And when we do a second derivative implicitly, it's not that it's extra difficult, it just requires a lot of tedious algebra. Okay? So, let's start by just finding dy dx. So do that first. Let's see if you can find dy dx. Go.
Oh, so you're method acting?
I forgot to put it back.
No, bro, that's your work. Everyone else tell them how to spell it. What's the
There you go.
Okay, did you get that?
Yes, in fact, I did.
Yay! Okay, good. That means I did it right too. Okay.
Well, I wouldn't.
I do double check myself with y'all. That's why I have y'all do it. Because sometimes I make mistakes, you know. Like the derivative of 4 is 4 instead of 0. Okay, things like that happen. All right. Now, let's talk about how we would get the second derivatives. Because this is still implicit. Okay, so this is still implicit. We're taking the derivative with respect to x. So, when I get to the next spot, all right, I take the derivative of dy dx. That is my second derivative. So, d squared y dx squared. All right. To help myself avoid the quotient rule, I'm going to bring that 2y minus 7 up as 2y minus 7 to the negative 1. Okay? So doing a little finagling. Okay? Now, I'm going to do a chain rule. So negative 1 times 4 would give me negative 4. 2y minus 7 to the negative 2. All right. And then times the derivative of the inside stuff, which would be 2 dy dx. Okay, so does everybody agree with that?
Of course.
If we didn't, we weren't going to tell you anyway. All right, so here we go. Simplification-wise, the negative 4 and the 2, I could multiply together to get negative 8. I could drop the 2y minus 7 back down as squared and a dy dx. Okay? Now, the problem here is I can't have a dy dx in my answer and a d squared y dx squared. Okay? So Parker's pointing. What do you want me to do, Parker?
We know what dy dx equals.
We know what dy dx equals. We just did it a few minutes ago. All right? So we're going to plug it back in. We're going to substitute that. Okay? So my second derivative is going to equal negative 8 over 2y minus 7 squared times 4 over 2y minus 7. Well, let's make that as pretty as possible. So multiply across, negative 32. On the bottom, how many 2y minus 7s do I have? I have 3 of those. That is my second derivative. Okay, so in implicit, okay, when you do a second derivative, you're going to get a dy dx, okay? You have to go back and substitute it in, okay, from where you solved for it previously. Now, that being said, it's really important that we simplify dy dx if possible. So if it ends up that I can factor out a 5 from the numerator and the denominator, we should, okay, and reduce it because that's going to make taking my second derivative a little bit prettier with fewer numbers. Okay, so let's do another one.
Sorry, this is already issues.
Okay, I got more. Okay, I'll get them out while y'all are starting this one. Okay, all right, here we go. This one's multiple choice, which is nice. Okay, have at it. See what you can do. I'm gonna get some more snot rags.
I'll take my chance. I'll just eliminate one off.
Okay.
Bless you.
That was a lot of dirt over there or something. Woo!
Golly.
We're all allergic to calculus today. Every day, but it's okay. All right, there's the first derivative, so you can check your work.
Oh, wait.
Okay, I got it. I just forgot to.
Yeah, always reduce.
Got that.
You know, it's observed by, I'll do that in.
Me
It
too.
won't be fine.
All right, so we need to walk through that second derivative because it gets, with that quotient, it gets a little wonk. Okay, just a little bit, all right? So let's do the second derivative.
I was so,
Were you close?
yeah.
Okay. So d squared y dx squared, so that's going to get the left side. The right side, we're going to have to do a quotient rule. Okay? So ho d high minus high d ho over ho ho.
How come you can't do y to the negative 1?
Do what? How can I not what?
Do y to the negative 1. Both ways.
You could. It should work out the same in the end. Okay. All right. So I'm going to simplify that a little bit. Okay. So that gives me negative y plus x times dy dx all over y squared. Now, because this one is numerical, we could stop here and start plugging in numbers. Okay. But I want to show you the algebraic simplification because there's going to be one day where there aren't numbers and it just wants the algebra, okay? So let's just kind of walk through it. We've simplified all we can, and now we go back to that step Parker said, and we have to substitute, okay? So I'm going to take negative x over y, and I'm going to plug that in for dy dx, okay? So that's going to leave me negative y plus x times negative x over y divided by y squared, okay? We cannot leave that as a complex fraction, all right? So let's simplify some more. So this is going to give me negative y minus x squared over y, all divided by y squared. I need to take this numerator and get a common denominator, okay? What would my common denominator be in just that numerator? It'd be a y, right? So that would give me a negative y squared over y minus x squared over y. Okay, it's just got a common denominator. All right, the first one didn't have a denominator at all, so we multiply top and bottom by y. Okay, once we've done that, that leaves me with negative y squared minus x squared all over y divided by y squared. Well, what happens when we divide a fraction in something else? Keep, change, flip. That's a y squared. Nope, that's a y. Times 1 over y squared. In the simplified algebraic form is negative y squared minus x squared over y cubed. Okay, so I just wanted to show you the algebra in that. Okay, because there will come a time, hint, hint, your test, where you have to solve that out algebraically, okay, and it's not numeric. Okay, so take a second and make sure you understand all that algebra. I know, it's nasty, it's tedious, it's nasty, it's all the things you didn't love about algebra in the first place.
No, maybe when you're done, could you do it the negative?
Yeah, I will. I'll go back and do it with the, yeah, I will. And we'll see if we get the same answer in the end.
I did it. I don't know what happened.
Okay.
Yeah, I just plugged it in and stuff.
All right, so let's go back and let's actually do the problem, okay? The problem says, hey, plug it in for the ordered pair 4, 3, okay? So I'm going to kind of go over here and do this to the side for the ordered pair 4, 3, okay? So my second derivative, all right, says that I'm going to take negative y, so my y was 3, so negative 3, plus my x value, which is 4, times dy dx. Well, dy dx was negative x over y. Okay, so negative 4 over 3. And I'm going to divide it by y squared, so 3 squared. Okay, because we just want a numerical answer. All right, so that's going to give me negative 3 minus 16 over 3 over 9. On the top, that's where I'm going to need that common denominator again. So negative 25 over 3 divided by 9, or negative 25 over 3 times 1/9. So my answer is negative 25 over 27. Okay, I combined this up here at the top. This gave me a negative 9 over 3 minus 16 over 3, which was negative 25 over 3. Okay, so when it's numeric, you really don't have to simplify the algebra. Okay, you can just, because it's going to give you the ordered pair, you can plug it in and go from there. Okay, so let's do it. Let's do the second derivative as a product instead of a quotient. Okay, so I'm just going to draw a line and keep going at the bottom. You can or cannot write this down. It's totally up to you. Okay, so we had dy dx equals negative x over y, and Oak was like, let's do this. Okay, so it's going to be product rule this time. So d squared y dx squared first times derivative of the second. So it's going to be negative 1 y to the negative 2. And then plus, oh, forgot my dy dx. Dy dx plus second times derivative of the first. Okay, so that's going to give me a positive x over y squared dy dx minus 1 over y. Okay, algebraically we would substitute in the dy dx. So x over y squared times negative x over y minus 1 over y will give me x squared over y cubed minus 1 over y. My common denominator would need to be y cubed, so I would multiply the second fraction by y squared over y squared, and I would get x squared minus y squared over y cubed, which is the same thing as what we got. Just missed the negatives, or everything's switched the sign. Okay.
So go to the, like, the big office?
Yeah, you have to punch in your number that you're leaving.
Okay.
Okay.
All right.
All right, see you, bye.
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 Good luck.
I'll be back.
Okay.
Not this class.
Not in the next class, okay. We're all gonna be so sad if she doesn't get in. Because we're so invested.
What's she doing?
It's part of her interviews for the Naval Academy. There's so much you have to do for that. Found your mistake?
Well, I just didn't do kind of.
Yeah, gotta do the product rule. It'll get you every time. Okay, all right, so,
Oh, wait.
oh, going back.
16 minus 9. So what is that? Four squared 16 minus y squared 9? Yes. Like, when you do x squared minus y squared?
Uh-huh. So that would be 9 minus 16, which is negative 9. No, negative 5. Mm-hmm. And then 16 cube, oh. Did I miss a sign somewhere?
Yeah.
Oh, negative x squared. There it is. I found it. It would come out the same. I missed my negative right here. X times negative x being negative x squared. Thank you. It's little things. Tedious. Okay, here we go. So your assignment today is on multiple pages because they do higher order derivatives throughout the whole chapter. So it still works out to about the same number of problems. So page 130 to 131, 33, 35, 56. Page 152 to 153, 39 and 48. So I'm just trying to give you some different ones to look at. Page 165, 29 and 31. Page 176, 27 and 29. Okay, so they're all asking for a higher order derivative, but they're spaced out throughout the chapter. Okay, and then go ahead and do your wrap up. All right, don't miss those points. And that's it. Good job. That's all of that unit. It's a lot. You got to study. Make you some flashcards if you're not sure about all the derivative formulas. Okay? They will help you.